China just built a battery the size of a coin that runs for 50 years without a single charge, no cable, no wall socket, nothing. And the next version is already being built for 100 years. It is not a prototype sitting in a lab somewhere. It is already in mass production. It runs on nuclear energy. And while the US, UK, and Europe have been publishing research papers on this technology for decades, China went ahead and actually built it. Imagine buying a phone today, handing it down to your child, and that child handing it to their child, and it still has never once been plugged in. That is the scale of what China just made real. And what is inside this coin-sized device is so bizarre that when you hear it, you will not believe a battery can work this way. If you want to know exactly how China pulled off what the entire world could not, hit like and subscribe, because this story gets wilder from here. And it all starts with the science hiding inside that tiny coin. How this battery actually works. The official name is the BV100. It was developed by Betavolt, a startup founded in Beijing in April 2021, 3 years from founding to mass producing the world's first commercialized miniaturized nuclear battery. While research institutions in the United States and Europe were still presenting academic papers at conferences, China was building the factory. The BV100 measures just 15 by 15 by 5 millimeters, barely larger than your thumbnail, and it generates a continuous electrical output for 50 years with zero recharging required. The next generation version, already in development, is targeting 100 years. 100 years of power from a device you can lose between your couch cushions. Now, the word nuclear tends to make people stop listening to everything else immediately. So let us be very direct about what kind of nuclear technology this actually is, because it is nothing like what you are picturing. There are no fuel rods. There is no reactor vessel. There is no controlled fission chain reaction. The BV100 runs on a completely different physical process called beta-voltaics. And once you understand it, you will realize it is one of the most elegant ideas in the entire history of energy science. Inside the BV100 is a radioactive isotope called nickel-63. Radioactive materials naturally decay over time. That is just what they do, continuously, at a rate determined entirely by physics, with no way to speed it up or slow it down. As nickel-63 decays, it releases what are called beta particles, a constant stream of high-energy electrons firing outward from the material with no external input, no heat, no combustion, no chemical reaction. Pure atomic physics, running on its own clock. Scientists have known about this phenomenon for decades. The challenge that nobody could solve at any commercial scale was, how do you catch those electrons and turn them into usable electricity? Betavolt answered that question with a material that no other company in the world had successfully manufactured and deployed at scale. A fourth-generation diamond semiconductor, not silicon, not the chips inside your laptop or smartphone. A real, synthetically grown, single-crystal diamond layer, just 10 microns thick. To give you a genuine sense of how thin that is, a single human hair is approximately 70 microns across. These diamond layers are so thin they are essentially invisible to the naked eye. Betavolt then takes a sheet of nickel-63, also just 2 microns thick, and sandwiches it between two of these diamond layers. When the nickel-63 decays and fires beta particles outward, those particles strike the diamond semiconductor and knock electrons loose inside the crystal in a perfectly controlled, continuous cascade. This creates what physicists call electron-hole pairs, and those pairs generate a clean, stable, uninterrupted electric current. Think of the diamond as a nuclear solar panel, except instead of waiting for sunlight to arrive, it captures the invisible energy of atomic decay that never pauses, never dims at night, never weakens in winter, and never stops for any reason whatsoever. Each individual sandwich unit is fully modular. You can stack hundreds of them. You can connect them in series for higher voltage or in parallel for higher current. The output scales to whatever your application demands. The current BV100 delivers 100 microwatts at 3 volts, and a 1-watt version is already under active development. But the number that genuinely stops engineers in their tracks is the energy density figure. The BV100 stores 10 times the energy density of a conventional lithium-ion battery. The lithium-ion cells powering the best electric vehicles and the most advanced smartphones on the market today represent the absolute peak of chemical battery engineering. China's nuclear battery stores 10 times more energy per gram of weight. That is not a marginal improvement. That is the kind of leap that defines an era. Why the safety story is just as shocking. The safety profile of this battery is, in its own way, just as jaw-dropping as the performance numbers. Beta particles from nickel 6-3 are low-energy electrons. They cannot penetrate even a thin sheet of aluminum, let alone the diamond casing surrounding them inside the BV100. There is no external radiation, there is no leakage. The battery does not irradiate the device it powers, the hand that holds it, or the body it sits inside. You could hold this battery with no protection at all and be exposed to zero measurable radiation. That is not a marketing claim. That is verified physics. Betavolt pushed that safety validation all the way to the most extreme test possible. They had the BV100 certified for implantation inside the human body. This battery can be surgically placed inside a patient and will sit there, silently powering their pacemaker, their cochlear implant, their neural stimulation device, their drug delivery system, for decades, without exposing the patient to a single harmful particle. The regulatory certification required to implant a nuclear device inside a living person is not handed out to press releases. China built a nuclear battery and earned clearance for it to go inside human beings. The end-of-life story is equally remarkable. When the nickel 6-3 finally exhausts its decay cycle after 50 years, it does not leave behind nuclear waste. It does not produce contaminated material requiring disposal in a specialized facility. The nickel 6-3 transforms naturally, through its decay process, into a stable, non-radioactive isotope of copper, regular copper, harmless, recyclable. The battery self-decommissions into a material you could theoretically melt down and reuse. In a world where lithium-ion battery waste has become one of the fastest-growing and most difficult environmental problems in the technology industry, China just introduced a power source that generates no toxic end product whatsoever. The BV100 also operates across a temperature range that disqualifies virtually every other battery technology on the market. It functions reliably from -60 degrees Celsius all the way up to 120 degrees Celsius without any performance degradation. That range covers every environment on Earth and most environments in near-Earth orbit. Deep ocean trenches, polar research stations, volcanic monitoring equipment, satellite components cycling between the freezing shadow of space and the intense heat of direct sunlight every 90 minutes. The BV100 does not care. It just keeps running. The industries this will turn upside down. Start with medicine, because the transformation there is the most immediate and the most personal. Cardiac pacemakers currently require battery replacement surgery approximately every 7 to 12 years. That procedure involves anesthesia, a chest incision, a surgeon physically accessing the implanted device, a recovery period, and real medical risk, especially for older patients who may already be in fragile health. A 50-year nuclear battery makes that surgery a thing of the past. The physician implants the device once, and the battery runs for the rest of the patient's life without intervention. Multiply that across the hundreds of millions of people globally who depend on implanted medical devices, and the scale of what changes becomes almost incomprehensible. Cochlear implants, neurostimulators, retinal prosthetics, insulin delivery systems, brain-computer interfaces. Every one of these devices stops requiring repeat surgeries, and starts working the way technology always should have worked. The satellite and space industry faces an equally profound disruption. Solar panels in orbit degrade steadily under constant exposure to cosmic radiation and extreme thermal cycling. Chemical batteries on board spacecraft have limited charge cycles and finite lifespans. Both of these constraints shape mission planning, satellite architecture, and ultimately the operational lifespan of everything humanity puts into space. A nuclear battery rated for 50 years changes all of that. It operates without sunlight, which matters enormously for deep space missions, where the sun is too distant to power solar arrays. It is immune to the radiation environment that slowly kills conventional electronics. China is already designing satellites and long-duration space probes that incorporate this technology into their core power architecture. The Internet of Things may be the largest single application by sheer device count. There are an estimated 15 billion connected devices operating on Earth right now. From moisture sensors embedded in agricultural fields, to structural monitors built into bridge foundations, to weather buoys floating thousands of miles from the nearest coastline, every single one of these devices has a battery problem. They require maintenance schedules, supply chain logistics, replacement crews, and enormous ongoing operational costs just to stay powered. A nuclear battery with a 50-year lifespan reduces the cost and complexity of maintaining a remote sensor network to nearly zero for half a century. Deploy the device, leave. It will still be transmitting accurate data when the engineers who installed it have retired. The defense and autonomous systems sector is perhaps the most strategically significant area of application, even if most of what is happening there remains out of public view. Long-endurance autonomous underwater vehicles, extended duration reconnaissance systems, high-altitude persistent surveillance platforms, covert infrastructure monitoring devices. Every category of autonomous system that exists today is fundamentally shaped by power endurance limitations. Those limitations are now negotiable in ways they have never been before. And that changes the calculus of strategic technology in ways that governments around the world are only beginning to quietly process. Where this is all going next. The 50-year battery is not the finish line. Betavolt has been explicit about that. The BV100 is the first commercial product in a development roadmap that extends towards significantly longer operational lifespans, higher power outputs, and alternative radioactive source materials. Strontium-90 and promethium-147 are both under active investigation as isotope sources for future generations of the battery, each with different decay timelines and energy output profiles. The 100-year battery is not a theoretical aspiration written in a grant application. It is the next engineering milestone on a schedule that has already delivered its first product to market. The diamond semiconductor platform that makes all of this possible also has consequences that stretch far beyond battery technology. Silicon has been the foundational material of global electronics for more than 70 years. Every microprocessor, every memory chip, every transistor in every device you have ever touched was built on silicon. Gallium nitride improved on it and enabled more efficient power electronics. But diamond as a semiconductor material surpasses both in thermal stability, electron mobility, and operational tolerance for extreme environments. By cracking diamond semiconductor fabrication at a commercial manufacturing scale, China has not just built one revolutionary product. They have established mastery over a material that will underpin the next generation of computing, medical electronics, aerospace hardware, and quantum technology. The nuclear battery is the first application. It will not be the last. The global scientific response has been a mixture of genuine awe and the standard demand for independent third-party verification, which is exactly what the scientific community should do when a claim carries this level of significance. But the verification process has a starting point this time. The product exists. The manufacturing facility exists. The patents are filed in Beijing, with international coverage extending outward. Pilot units have been tested and confirmed by independent reviewers. This is not a concept. This is a commercialized, mass-produced device already shipping. What Betavolt has actually done, beneath all the technical details and application scenarios, is something more philosophically significant than any individual specification. They have broken the assumption that has sat underneath every piece of technology ever built. The assumption that power runs out. That assumption is so deeply embedded in how engineers think, how product designers work, how infrastructure is planned, that most of the technology world stopped questioning it entirely. Betavolt just questioned it, with a coin-sized object made of diamond and nuclear physics. And the answer they came back with changes everything. Whoever controls the future of energy controls the future of every technology built on top of it. Every satellite, every medical device, every autonomous system, every sensor network, every piece of critical infrastructure on this planet runs on power. And right now, sitting in a production facility in Beijing, smaller than a coin, converting the invisible energy of atomic decay into electricity without a single wire, plug, or charger anywhere in sight, is a battery that may be the single most consequential object manufactured in the 21st century. China built it first, and the rest of the world is only beginning to understand what that means. If this blew your mind, hit like and subscribe so you never miss what comes next on this channel. Which part shocked you the most? The 50-year battery that never needs charging, the 100-year version already under development, or the fact that this diamond semiconductor is 10 times more energy dense than the best lithium-ion battery in the world? Tell us in the comments below. We read every single one. And if you want to see more of China's most insane technological breakthroughs, go check out our other videos on the channel.